Claire's done a lot of work for the Internet of Things, and her talk title is Interusability, Designing a Coherent System UX for Connected Products. Put your hands together, please, for Claire.
Thank you. So I think we just had a lesson in the things that can go wrong when you try and get one device to work with another one. Now imagine everything in the world around you all the time being like that. It's going to be fun, isn't it? I was going to introduce myself, but I guess I don't need to so much now. I'm an independent UX and product consultant. I'm also the lead author of a book called it came out in May called Designing Connected Products: UX for the Consumer Internet of Things. Which has been my kind of area of expertise for about the last 4 or 5 years. But I would like to just say that I'm actually almost a little bit emotional to see kind of 600 UX people, mostly living and working in the north. Because I lived in Leeds in the 90s, first studying and then working at the Press Association. And I think I had the first UX job in Leeds, thanks to a very far-sighted boss at the Press Association. Who saw the need for information architecture and usability testing. And when it sort of came time to think about moving on for something else, I basically had to move to that London because I think I had the only UX job in Leeds. So I'm really pleased to see that things have moved so much. It's brilliant to see you all. So I'd like to start with a quote from an analyst called Benedict Evans from Andreessen Horowitz, who, if you don't read him, you should. He's a very super smart guy. And he said, my grandfather could probably have told you how many electric motors he owned. There was one in the car, one in the fridge, one in his drill, and so on. My father, when I was a child, might have struggled to list all the motors he owned, how many exactly are in a car, but could have told you how many devices were in the house that had a chip in. Today, I have no idea how many devices I own with a chip in, but I could tell you how many have a network connection, and I doubt my children will know that in their turn. So when we talk about the connected things and the Internet of Things, a lot of buzz about this and a lot of a certain amount of hoo-ha even in the kind of mainstream press. The kinds of visions of what this future is going to look like, what it's going to be like, are often accompanied by a picture that's something like this. And it's all the things in your house kind of magically anticipating your needs and coordinating with one another, and everything's very shiny and clean and stuff. And that's sort of all very well. But the reality of this stuff right now, and I'm speaking as someone who's very enthusiastic about this stuff, but also realistic about where it is, about where the state of things, is really more like this. This is a line from a review. I used to not tell people whose product it was, but seeing as they don't exist, they're kind of now being acquired and not doing very well. And it's anyway, it's Wink basically. I don't mind being honest. This is a line from a review which was largely very positive about the Wink system. But it had this sentence that said, it's a bit glitchy, but it's okay, you just have to be in the room at the same time. And what they meant by that was that if you had the Wink light bulbs and you were controlling them from a smartphone app, sometimes the smartphone app would tell you that the lights were on when actually they were off. And sometimes it would tell you that they were off when they were on. But it's all right, because you're in the room, so it's fine. You can just see whether the lights are on or off, can't you? I was like, and this is why we put the internet in things? Anyway, so my interest in this stuff is, I'm not really an innovation person. I'm more of someone from a usability background, I suppose. I'd like to be an innovation person because it sounds fun. But my interest really is in how we get this stuff to feel normal and how we get it to make sense to mass market consumers. And clearly, if it's telling you the lights are on when they're off, and and vice versa, that's not really kind of acceptable. That's not the kind of thing that the mass market's going to buy just yet. But I'm enthusiastic about this stuff. But one of the things that I often find, it's a very technically driven field. Often the kind of discourse around design is focusing on one of two things. It's either the UI of the apps themselves, so things like here we have the lights, the app for the Philips Hue bulbs, or it's the industrial design of the devices, the embedded devices, the kind of specialized connected devices themselves. So things like the Nest thermostats are an iconic example of nice industrial design in this space. And those things are important, but they're not the whole story. So it's possible to create a lovely app, and a lovely piece of hardware, and yet for the whole thing still not quite to work. I think there are a couple of challenges that I've been working in, particularly in connected home technology for the last few years. A couple of challenges that I came across that I hadn't really expected coming from a pure software background. One of them is that a lot of complexity arises from the fact that you're working with systems of multiple devices. So we have devices that with specialist functions. So this is the why things ecosystem. There's a bathroom scale. There's a blood pressure monitor. There's cameras. There's a baby monitor. There's their activity trackers. That kind of stuff. All of these do different things. So functionality and interactions distributed across different devices with different capabilities. And users kind of have to understand something about the relationships that exist between those things to understand how the whole thing works. But most of us are much better at thinking about concrete things than we are at thinking about relationships between things. I'll explain a little bit more about this in a minute. The other thing is that I don't think we yet expect things to behave like the internet. So you think about when you use the internet through through a PC or through a mobile. Maybe we have this mental model that helps us understand that sometimes things aren't sort of perfectly smooth. Sometimes a web page might be a bit slow to load. Your emails might be a bit slow to download, or sometimes a Skype call may fail. These are latency and reliability issues. And it's frustrating when that happens, but we have a mental model that allows us to understand that that's going to happen, and also to know what to do about it, even if it's disconnect, reconnect, try later, whatever. The thing is that when you put that stuff into the real world, it starts to feel very strange. So if you think about, if you're flipping a light switch, you expect the light to come on, a physical light switch, you expect the light to come on pretty quickly, right? If it took 10 seconds, you would think that perhaps something was a bit broken. If it took 30 seconds, you would be well convinced it was broken by the time it actually came on. So our expectations of the physical world are that it responds to us kind of immediately and reliably. There aren't these kinds of delays. The instructions don't go missing en route from the light switch to the light bulb. But when you put the internet into those things, all of those latency and reliability issues that you may have across a network start to sort of manifest as properties of the real world. And if we're not careful, it can start to feel quite broken. This is my gnarly diagram trying to make sense of it all with vague nods, I suppose, to Jesse James Garrett's elements of user experience and also to the technical networking stack, which I've spent too much time looking at over the last few years. And so this is my attempt to make sense of the different facets of user experience design that exist when you're designing for connected products. And so at the top layers, we have the most visible things. So we have UI design of apps, maybe that's visual design. We may have, there may be other kinds of UIs, perhaps voice. There's an aesthetic layer, and then related to that is an interaction layer, what the things do, how they behave. There's obviously the industrial design of the things themselves, can be a big part of the user experience. And then below that, we get into what happens when you have multiple things working together. I'm not sure how well you're going to be able to read this at the back. I apologize. So the layer below that is what I would call interusability. And this is what happens when you have interactions that span multiple devices. And those things have to feel as if they're working together coherently. And underpinning that is the conceptual model that the user has of the system. So how do they understand that it works? And these are going to be the focus of the talk today. So I'll go into those in a bit more detail in a second. Underpinning all of that is commercial and technical concerns. And I think these really are areas of concern for design as well. So one of them is service design. If you buy a connected product, it's not a one-off, I hand some money over for a physical thing and that's the end of my transaction with that company. They have to provide an internet service that keeps that thing running. They might need to provide me with installation. They might need to provide me with support. So very often there's a kind of online and even offline service ecosystem around these products, which is really important to keep them up and running and very much part of the customer experience. Then there's the productization. This is a massive challenge for lots of connected things and something I could probably rant about for the rest of the talk if I didn't stop myself. This is the idea of this is about having a good value proposition. This is about defining who it's for, what it does for them, what benefit it provides, how people just understand what the thing is and why they would want it. And then underpinning everything is a technical layer. And I hadn't thought about this as hard as I should have done when I used to work on software services. When I came to work on things that had a hardware component as well, that were lots of bits knitted together, I really came to appreciate how important this was and how important it was to engage with engineers around these things. So this is stuff like, if you haven't got the right APIs, you ain't going to be building the right functionality with the UX. So, you know, if you've learnt about user needs, you need to go and talk to the engineers and make sure those things are being addressed with the APIs. And it's also about some really complicated stuff, which is how you get lots of different devices to coordinate in common sense fashions. How if you take a connected washing machine home, it doesn't go, hey, I can talk to the doorbell, because that's a silly thing to do. And that's another one for another day. But anyway, so today we're going to focus on the stuff which is in the middle of this diagram, so the interusability and conceptual model. So let's talk about conceptual models. This is all about the user's understanding of how the thing works. You may be familiar with this term from Donald Norman, kind of way back. And I see this as sort of being the glue in between people understanding the value proposition and what the thing actually does, and, you know, do they want it or not, and the interaction model, how do they use it. So you've got to have some sense of how does this thing actually work. It doesn't need to be very detailed, it just needs to be a framework that you can build on to understand how to use it. Now, non-connected things tend to be conceptually quite simple. So if you think about a light, you have a switch. You have a bulb, you have some electricity, you have a switch, press the switch, the bulb comes on. That's great. We all understand that. When you put connectivity into that system, other things start to appear. So this is a model. Again, I apologize if you can't read it very well at the back. This is a model, I'll attempt to explain it, of a connected lighting system, something like a Philips Hue. So you've got a bulb, and the bulb is connected. And the bulb, in the case of the Hue, talks to this round white thing, which is a bridge or a gateway. So the bulb's not actually on the internet, but it talks to a gateway, which then connects outwards to the internet. So then you have this kind of cloud internet service, and then you have the apps through which you actually control the system. So there's a couple of things here. First of all, you've got this mysterious white box, an infrastructure device which didn't previously exist in that system. And those are things that people often find a bit confusing and don't understand. And in my research, I found that they're often things that get unplugged because somebody wants to use the vacuum cleaner, and they don't plug them back in again because they didn't really know what they were doing in the first place. And then people start moaning at you that their heating stopped working and their lights have stopped working, and it all comes back down to this thing. The other thing that's more complicated about this is that it requires people to think about the interconnections between these things. So you've got multiple points of failure here, and you've got different things that can happen if different bits fail. And this is really asking people to start, we don't think too hard about how stuff works, but actually in this case, if you buy one of these systems, you need to have some idea of which bit's doing what, because you need to understand some of those ways that it can go wrong and what to do about it. So that's essentially things like, one of the key benefits of connected lighting, one of the things that's often sold as a benefit is the ability to create automated rules. So you can say, well, I want to turn the lights on at 8 o'clock when I'm not at home to make it look like someone's home. As a security measure. And that's great, but depending on the kind of system you've bought, what happens if your internet connection goes down? Well, in some cases, it will stop working, and in other cases, it will continue to work. So if you've got rules that sit either in the cloud or less commonly in the mobile app, that rule runs, and then it can't get through to the house to turn the lights on. So that's not going to work. If the rules, on the other hand, are running on the gateway, and this doesn't happen, but theoretically in the bulb, then actually they'll be fine. So there's all this stuff. We're basically asking users to think about where the code runs, which is quite complicated. And if you just thought you were going to buy some lights, which are a pretty established mass market consumer product, you not only have to think about price and aesthetics and features, you also have to understand how these different things connect, and they all connect in different ways. All of these connected light bulbs will connect to the internet, and some of them connect directly, some of them don't. They all have a different model, and you've got to start understanding that. And this is a lot, really, to ask of mass market consumers. So what can we do about some of this stuff? Well, there's two things. You can either try and make it very explicit what's actually happening. And these are examples of a couple of systems that try to do that. So the one on the left is Lowe's Iris. This is an American home automation system that runs on I didn't design this, but I worked for the company that made the underlying I used to work for the company that made the underlying platform. And this takes a very, very explicit approach to everything. And if you can see that up in the top right of the screen, there's a little green light on the mobile app. And what that's telling you is that there is currently a connection, an active connection to the gateway in the home. So if you say, I want to change the temperature of my air conditioning or my heating, we guarantee you that instruction will be passed to the gateway. We don't necessarily guarantee you that it's actually going to get past the thermostat, but we can promise you that it's going to go to the gateway. The one on the right is the Berg Cloud Bridge. I imagine most or all of you are familiar with the design agency Berg, who sadly don't exist anymore. This was the bridge. This is another gateway device, and this was used to connect a little printer to the internet. And Berg apparently experimented with a number of different designs and settled on the idea that you had to make network connectivity really, really explicit. So it tells you whether there's power, it tells you whether the Ethernet's working okay, it tells you whether it's got an upstream connection to the cloud service, or whether there's a downstream connection, the local connection to the devices. But again, this is a lot of stuff to be burdening people with. So the other approach you can take is just to go, well, look, too much detail, just simplify it. There's a mature consumer product that most of us would know what to do with, which does this very well, which is the automatic gearbox. Most of us would struggle to explain in any depth how a car's transmission works, but we all know more or less what to do with one of those things, and that's fine. We can use it quite successfully on that basis. A more connected thingsy type example might be iBeacons. Is everyone familiar with beacons? Beacons, nodding, waving. There's a few hands. I don't know if you're just being quiet but anyway. So beacons are little Bluetooth devices that they're fairly dumb. They just kind of broadcast an ID. And one of the uses for them one of the early uses for them has often been in sort of retail settings so that the retailer knows when someone who is a regular customer walks in and is able to send them special offers like hey, welcome back, have a free coffee, something like that. And what the user really needs to know, which is often how this is described even in sort of fairly technical press, is just that you walk in and the beacon actually sends you the notification, and that's fine. And you can use it perfectly well like that. But it's not really what's actually happening. What's actually happening is a lot more technical. The beacon just broadcasts a unique ID, and in that ID, your phone, if you have Bluetooth on, detects that ID. There's a little string, text string in that, which identifies the app that beacon wants to talk to. And if you have that app, it will be woken up. It might check into the internet service. It might then see that there's a notification from that. And that will then be sent to your phone. So there's a lot more going on here than you really need to think about. And you know what? It doesn't matter if people don't know that, because it's just it's perfectly fine. Nothing can go wrong as a result of having a very simple mental model. And I think it'd be interesting to see how this stuff plays out. Obviously, people will get more accustomed over time to some of these complexities. But I think we're asking quite a lot of consumers, and I'd be interested to see how that plays out. So I'd like to look at the next level up. This is interusability. This is all about making multiple devices work together in a way that feels coherent. Now, I didn't come up with this term. I know that people have feelings as usability being a very specific part of UX, but into UX kind of doesn't really make sense. This model I first came across in a paper, a paper called Cross-Platform Service User Experience from 2010, and I found it stands up really, really well in my own work on IoT. So the first aspect of this is composition, which is thinking about which device you want to do what. And so you have to make decisions. This is a tale of two thermostats. You may have seen these. The one on the left is the Tardo. Now this is a German-made system, but you can get it in the UK now. The thermostat itself is basically a white plastic box with almost nothing on it. The very first version actually was just a white plastic box with no display, no buttons, no nothing. The new version now will actually tell you what the temperature is, and I think there is a single button on it. But essentially, their philosophy has been to put all of the interactions onto a smartphone app. It's a very smartphone-dependent system. It does things like warming the home up when it thinks you're coming home, trying to predict occupancy based on whether the phones are in or out of the house. But essentially, what that kind of model allows you to do is to save money on manufacturing the hardware. And it also, because you're not putting buttons and display things onto it, which jack up the bill of materials quite substantially. And it also gives you some flexibility, because it means that if you want to change functionality or change the interface over time and improve the way the system works, you're not tied to a hardware interface that's got so many buttons and these things fixed into the screen. But the downside of that, obviously, is that if you've got people in the house who actually don't have access to a smartphone at that point, then they're a bit screwed. The one on the right, and I've realised I've got the old one here through some interesting foo with slides earlier on today. This is the British Gas Hive, and they have actually released a much nicer, kind of nicer looking one, a much more futuristic looking one, shall I say, now. But this is the one that I have in my own house. And this is a fairly conventional kind of thermostat that has a fixed LCD screen. So I actually originally worked on that screen, and you have to decide all the things you want on that LCD screen that you might ever want for the lifespan of the device up front, and they get baked into the screen and you can't change them later. But you can pretty much do everything you want to do on the device itself or on the smartphone app. So, if you, for any reason, you don't have access to the phone or to the internet service, you can still control the heating. I don't think either of those is particularly, better or worse. It really depends on who you're targeting and what it's for. But this is a very common pattern of decisions that we see being made with connected products. These are some irrigation controllers, which is a thing that are big in parts of the States, but obviously we don't need here, and particularly not in Manchester. On the left is a blue spray. This is an ugly blue plastic box that looks like it's designed to sit in a bush somewhere and turn on your sprinklers. The one on the right is a sky drop, which has been designed to sort of look a bit more swish on the wall inside your house, but essentially does the same thing. And so one of these on the blue spray, all the interactions are on the smartphone app. On the sky drop, everything is pretty much mirrored between the two devices. And this is one of the biggest decisions you have to make, really, around connected things, is which features will you leave out? Which features can you assume will be okay to handle on a software interface as opposed to baking into the hardware? And it's all these questions of cost and context of use kind of come into play. And you might think you're being minimal, but actually you might leave something really important off. And where's the line between that and doing too much in hardware and restricting yourself in the future? These are the drop kitchen scales, which I have, and they're very nice, and that you require an iPad app to use with them. And they walk you through all sorts of recipes and kind of adjust quantities for you, and that's lovely. But they are lacking one major thing, which means that I haven't thrown out my old kitchen scales, which is a screen. So if I just want to weigh 14 grams of coffee beans in the morning, if I wanted to do this, I would have to go and find the iPad and connect it to the scales via Bluetooth, because you don't leave your iPad in the kitchen all the time, do you? It's like, anyway, I think the second generation of this product is almost certainly going to have a very small LCD screen, and it would be a lot more useful to me if it did. So the second aspect of interusability is consistency. Now this is something that I imagine everyone's familiar with from the Nielsen's old school usability heuristics. This is all about users not having to worry whether different words, situations, or actions mean the same thing. It's about conventions they expect from the platform. So that's things like words and data, it's things like visual design, it's things like interaction architecture and interaction logic, the way you structure the tasks, the types of controls you use. Now with IoT, consistency is always one of those things that's kind of easy to understand, but actually can be really, really gnarly to try to apply. Because which things should be, you can't make everything the same, so which things need to be the same and which things should be different. And when you're dealing with devices that have very different form factors and people expect to interact with in different ways, it obviously isn't going to mean making everything the same. And sometimes the idea that people shouldn't have to worry whether different words and actions and that kind of stuff mean the same thing might be in tension with following platform conventions, which might be telling you to do very different things on different devices. This is a kind of flippant example, but this is the Hackable. It's a programmable ball for children. And I just wanted to use this as an example of, there's an iPad, there's a ball. We have very different expectations of the kinds of interactions that you have with an iPad and a ball. I wouldn't want anybody throwing my iPad around or dropping it or bouncing it. So, when you're dealing with very different types of devices, but you might be asking them to do similar things or getting them to do related things. So how do you make those things map? So from my experience, the top priority is that however different your UIs, features that do the same thing need to be given the same name. So one example I did a lot of research on heating controllers. One example is like silly things like you've got an old-fashioned thermostat that says timer or schedule, and you think it says schedule on it, and that's the automated schedule or auto, and you think timer is a better word for that, but you can't change what's baked into the hardware. It's a lot better just to kind of swallow it and say I'm going to use the same word in my smartphone app as exists on that device, because people already don't understand heating very well, and if you give the same function different names, they're not going to know that they are the same thing. So calling things the same is a simple thing that's really important. Then, if you have any device platform conventions, you need to follow those. There's some fairly well-documented differences between things like Android and iOS. So obviously, if you've got multiple smartphone apps, you want to follow the conventions of those devices themselves. But often, you may not have any there are no platform conventions for a thermostat, for example. And in that case, you want to think about being true or kind of honest with what a device actually does. And I use a Nest example here because I think they've done this quite nicely, having been through the pain of some heating controller projects where app designers were trying to kind of do very skeuomorphic representations of thermostats and dials on smartphone screens, and it's really a complete disaster because that just isn't how you interact with a touchscreen. What Nest have done is you control the wall controller by rotating a bezel, which makes a little clicking noise, which I'll come back to in a second. On the smartphone, obviously this looks very, you can tell that these are part of the same family of interfaces, but you tap on the screen. You can tap up or down arrows, or you can tap around the dial to adjust the temperature. And so it comes down to what's the best way to do the thing that people most often do with thermostats, which is make very small adjustments on these different devices. And the best UI for each of those is different. Now, the other thing I like about the Nest in terms of consistency is they've used not just visual but also audio cues to tie those two interfaces together. So as you rotate the bezel, it makes the little clicking noise. When you tap on the arrows or on the dial on the smartphone app, it also makes the same clicking noise. And that's a really subtle touch that makes these things feel like they're part of the same family. Where it gets very different is around interaction architecture. So surprisingly, we commonly think of connected products as being a startup makes a shiny thing and all the hardware and software gets developed at the same time. What's increasingly happening is what we call retrofit, which is kind of old school hardware like burglar alarms and things that people don't expect to replace every 2 years. People are finding ways to connect those and provide benefits of connected systems with the old-fashioned hardware. What that often means is you've got some kind of clunky, ugly, horrible box that's got a really nasty modal menu structure and arcane series of commands that you have to jump through. And you really don't want to be replicating that in any software UIs that you create. So feel free to throw all of that out. And finally, and I think this is the most for me the most interesting and one of the most challenging aspects of cross-platform design with embedded things. This is continuity. This is all about the fluency of the cross-platform interactions. This is about being able to do something on one device and see the effects on another device and have it feel as if you're interacting with a service and not a bunch of disconnected UIs. And so one not particularly new but nice example of this is the Kindle WhisperSync. If you're reading on one Kindle device and then you pick the book up in an app on a different device, it will offer to take you to the place where you stopped reading on the previous one. And in the US, this even works across audiobooks. So if you're listening on Audible and then you switch to the Kindle will take you to where you were in the Audible app, which is lovely. And it helps you feel as if you're interacting with the service. I'm reading the book. I'm not on my phone. I'm reading the book. Now, the problem with connected things is, and I apologize for going a bit technical here, it isn't always, designers think that this is all seamless. These things work together seamlessly, like the shiny kitchen at the beginning of a talk. But it often means handling interstitial states gracefully. So those are the bits between you doing this on one device and something happening on the other one. So a bit of technical context. So a lot of connected products, connected devices run on batteries because they have to. It's not practical to give them mains power. And maintaining an open network connection uses a lot of power. So most of those things will not be connected to the internet or local network all the time. They will connect only intermittently. They'll check in to see if there are new instructions, or when they have some important data to send, then they'll connect and send it. So in conventional UX, we tend to assume that things are mostly connected and that being unconnected is some kind of exceptional error state. But actually, this is the normal state of a lot of embedded devices. And the second thing is, as I mentioned earlier, there are kind of network issues. So networks are subject to latency, particularly the internet, and reliability. Sometimes things take a while. Sometimes they don't work at all. And we understand that in terms of software, but we don't necessarily understand that in terms of the real world. So the impact is that interactions won't always be smooth and immediate. You may have seen the Berg's CloudWash prototype. This was a kind of part design fiction, part prototype for a connected washing machine. It's a very nice video, beautifully made. I suggest you go and watch it if you haven't seen it already. But essentially what happens at the beginning is someone is setting a wash program on the smartphone. The display of the device itself changes to, it instantly kind of replicates this wash program and the machine starts up. While the voiceover says, oh, this is happening over the internet. And of course, if that really was the internet, you wouldn't necessarily be able to guarantee that that would happen. It might take 10 seconds, it might take 20, it might take 30. So let's think about the impact on UX of doing that. I'm going to talk about smart plugs for a second. Let's imagine you have a smart connected plug, which you can turn on or off, which is connected to a lamp. This has an effect on the UI design. I'm conscious I'm running a bit late on time now. So the switch does, you might say, a physical switch does two things. It both confirms that you have acted on it, so you can see that the switch has changed state. And it shows the state of the lamp itself, so it might show you that it's switched from on to off. But in reality, latency and reliability issues mean that flipping that switch, there might be a delay between flipping the switch and the action being executed. So what do? So you might say, well, actually, I'm going to create the obvious solution is a switch on a smartphone app, for example. You press on, the switch changes state to show you that the light's now on, and the light comes on, bingo. But actually, it isn't always going to work like that. So how do you handle that delay? So there's two things you can do. The first one is lie, basically. You can say, if you press the switch on the app, I'm just going to show you that the light's on. In the meantime, I'm going to go away and send that instruction to the plug. And if I get confirmation that that action was successful, that's fine. I will never tell the user that I've lied to them. The lamp will just be on and it will be fine. And if there's a problem, and I can't do that, I'm going to go back to them and go, yeah, sorry, which is what things like Philips Hue do. And it sort of works quite nicely for stuff like lighting, where it's not really the end of the world if it doesn't work. And there are parallels with this in conventional software UX. So Instagram do this as well. If you like something, it instantly someone's photo, it instantly shows that that was liked, even while in the background they're kind of running off and going, send that like instruction to the server. So, but it creates a nice, smooth sense of user experience. It makes you feel confident, I act on things and they happen. The second option is to be very transparent. And this is to say, when I press the switch and you go, okay, I'm sending that instruction for you to turn the light on. And off that goes, and you kind of wait and go, is this going to work? Is it going to work or not? And then when it gets confirmation, either that it happened or it didn't happen, it goes, yeah, I've done it, or no, sorry. And that's kind of very literal. And here are, there's examples of things that do that. The Wemo switch, Belkin Wemo switch, this is a connected plug, does it very subtly. If you turn a switch off from an on state, you get this little animation where it's sort of in an in-between state. And then when it gets confirmation, it is actually off. It shows you that it's off. The Lowe's Iris system I mentioned earlier is a lot more explicit. So this is someone changing the temperature on the water heater. It says, sending changes, please don't exit. And then you kind of stand there going, oh, what's going to happen? And then it tells you that it's changed it. So that's being very honest about what's actually happening. But it introduces the idea of failure into every interaction. So every time you do something, you have this kind of sense of uncertainty as to whether it's actually going to work. And the other thing that is a challenge for continuity is intermittent connectivity. So this is the idea of the things that run on batteries, which only check into the network every now and then. And it matters for UX, because what that means is that sometimes different devices will have different notions of what the state of the system is. So if you have, for example, this is a real example, but anonymized, a battery-powered thermostat, which only checks into the network every 90 seconds or 2 minutes to see if there are any instructions, and you're standing in front of it with a smartphone app and you turn the temperature up to 21, there is a period of a minute and a half, maybe 2 minutes, where one device may be telling you that the temperature is set to 21, and the other one will be telling you that it's set to 19, and which one is right. And you need to know something about how the system works in order to be able to understand that situation. And this breaks a really fundamental usability principle, the idea that the system state should always be visible. So there are things you need to do to manage that, and that might mean in some cases things like timestamping actions to show when the last instruction was received. And the right approach to all of these things, as ever in UX design, depends on context. If you're dealing with something like an elderly person's emergency alarm system, it's really important that you don't ever give them the impression, if they've summoned help, that help is on its way until you're damn sure it is. If, on the other hand, you're sending data from a smart meter, and there's a bit of a delay in connecting, it's fine. Just buffer the data and send it when you can. Nothing bad is going to happen as a result of somebody not knowing exactly how many watts they're using right now. I'd like to leave you with a final thought about all of this, which is that there are many more interesting challenges you might to investigate on your own. Hey, book promotion, but doing good consumer-grade user experience, that creating the kinds of experiences that consumers expect to have with products, with connected things, at the moment is actually surprisingly hard. I'd like to leave you with Larry Tesla's law of the conservation of complexity, which is the idea that as you make the user interaction simpler, you make things more complicated for the designer and the engineer. And there are an awful lot of challenges for designers and engineers in IoT. And I hope that many of you will have the opportunity, if you want it, to work on some of these things. If not now, then very soon. If you would like a copy of the book, we have a couple to give away. You can please tweet NUX4 and say that you'd like one, and we'll give one to the first couple of people who want one. If you don't manage to get one of those, but you would still like one, there is a discount code here, which I can also give to you in person, to get 50% off the ebook or 40% off print from O'Reilly. Or you can just find out more from the website. Thank you.
Thank you very much. I've got a couple of questions.
Okay.
There was an absolute flurry going on.
Ooh.
Right. Given the state of content on the web and the fact that there are things like Medium and Twitter and stuff like that, and we pour a lot of content into those, and we don't know if they are going to sustain themselves. If you take that and transition it across the Internet of Things and companies that do stuff with the Internet of Things and do products and stuff, and we start to adopt those, what happens if they close their doors?
That's a very, very good question. And, as you may know, Berg don't exist anymore, so any of you who bought a little printer have a nice little ornament on your mantelpiece now. It's an unresolved issue. It's not helped by the fact that a lot of these things are kind of closed source. I'm not, particularly technical open source advocate, but if you buy a thermostat, it's always thermostats, I'm sorry, but something like that, some piece of home infrastructure, you expect these things to last for 10 years. You don't expect that in 2 years' time the company that sold you that thing is going to go out of business and you're going to end up with a brick, basically. The one solution to that is for them to become, sometimes people open source it. But there's no money for anybody in supporting them.
Yeah.
So there's no the business model support. So it's a massive issue.
Yeah. And what do you see as being the biggest barrier to the Internet of Things?
Ooh. I'm seeing this from if I was a technical person, I would probably say interoperability, which is, without trying to get too technical, a lot of these things all talk different on many different levels. They can't connect together. They use different types of networks. They can't exchange data with each other very well. There's all sorts of problems on that. Because I'm not a technical person, I'm a design person, I'm going to say that I think it's actually around, some of it is around ideas, actually. It's around, we're still in very early stages of lots of people making things because they can make them, rather than solving real problems that people actually have. Yeah. And at the moment, there are lots of things out there which are interesting. but the gap between how people, the effort and cost required to sort of buy into those things is not justified by the value that people feel that they deliver. I used to work in home automation, and there's like 40 years history of home automation systems, at least 40 years, that never ever went mass market because people were like, I can draw my curtains myself. I don't need a computer to do that for me. I believe all of this stuff is going to happen because it's going to become so cheap to put the technology into things and so cheap to build it in that it's going to happen, and people are going to do terrible things with it, and they're going to do some great things with it. But right now, there's a lot of over-enthusiasm about the tech, perhaps, and not enough focus on the value.
And if Joe Blogs does some open source something with Internet of Things, and there are other products on the market from big companies, say for instance Google and Apple, how do you see that progressing?
That's an interesting one, because I think you don't want everything in your house to come from Google or Apple. The open source people don't always have the. There is an open home automation system, but it's a niche thing. It's not something that most of us would necessarily want to bother installing in our homes because it's quite complicated. I think increasingly we'll probably see devices that are actually that speak web standards, that can talk to each other. There's a sort of semi-interoperability state where things will talk to, you buy a product from one company, it will talk to another company's product over an API. In the cloud, which is great, but of course if the internet connectivity goes down, they're not talking to each other all of a sudden. So I think at the people are being quite conservative about it at the moment because security is a massive, massive, massive problem. Yeah. And that's why probably Apple's stuff is one reason that HomeKit is so doesn't seem to be doing very much and is very, very closed. Is because as soon as you open up. I think there was the iKettle last week, which is like one of those kind of pointless connected things. So you can turn your kettle on from your phone, okay. Some hackers exposed security people exposed a flaw in it that basically you can persuade the iKettle to give up your Wi-Fi network SSID and password quite easily. Compromising a kettle is kind of like, well, yeah, who cares? But once you're on the Wi-Fi network, you've then got all the other connected things, which make the assumption that anyone you allow to use your Wi-Fi can turn the lights on and off and control the thermostat and that kind of stuff. You're into other things.
It's going to be. I see it being our future, in some way, shape, or form. But because privacy and security are such big things, and TalkTalk just got hacked and 4 million users might have got attacked yesterday. It's just going to take time and a lot of work to kind of move forwards with it and see where we'll go. So quick last question, because I'm running over now myself. Similar question to Brian. If you had the chance to work on anything without any kind of monetary issues, what would you work on?
I don't know. That's a really hard question. I'm much better at analysing things and going, that's why that doesn't work very well, than I am at imagining futures. I think I do like working on home stuff, but not because it's necessarily there's lots of interesting industrial applications, probably with stronger business cases. I do like working on home stuff because it's an interesting set of social problems. Mm-hmm. So I would like to work on the platform, or essentially the kind of the low level, not even low level, the data models that allow us to have all of these things coordinate in common sense fashion. So this thing knows that this other thing that it should do this. They can suggest sensible ways of interacting with each other. So if the connected car knows what to do with it, knows not to bother talking to the connected fridge, but it knows the lights can sort of work in. Not lighting. But the problem of lots of connected things, and I'm sorry, it's just a long answer. The problem with lots of connected things is how do you get those things to coordinate? And you could spend your entire life just configuring which thing does what with which other thing, and very quickly lose track of it. And I'd like to work on that problem.
Big problem to solve.
Home or not.
big problem to solve. Thank you very much, Claire.
Okay.
Cheers. Thank you.